Hello everyone, and thank you for joining today's Space in Tech Lab seminar. For those of you who do not know me, my name is Sefer Jan, and I'm a research fellow here at the Space in Tech Lab. I'm stepping in for Dr. Kimon Krenz, who unfortunately couldn't be here today and asked me to host on his behalf. It's my pleasure to welcome Dr. Lianqing, who will be presenting her fascinating research on the relationship between stress and spatial configuration with a focus on stress-related brain activation. Lianqing is a postdoctoral researcher at the Chair of Urban Design and Planning in the Department of Architecture at TU Darmstadt. Her work focuses on healthy urban design, particularly on how macro-scale design factors and ground-level interventions shape community health and well-being. Her research has been published in journals such as the Journal of Environmental Psychology and Environment and Planning B, Urban Analytics and City Science. Her work explores design strategies for urban public spaces as mental health supportive resources, with the aim of informing evidence-based design guidelines. Before we begin, just a quick note, if you have any questions during the talk, please pop them in the chat and we'll make sure to address them at the end. And with that, I'm delighted to hand over to Dr. Lianqing Gu. The floor is yours.
Thanks. Hello, everyone, and thank you, Mr. Jant, for the kind introduction. And thanks as well for having me here today. I'm very delighted to have this opportunity to present one of our studies using space syntax, which we conducted in collaboration with colleagues from Charité, Universität Medicine Berlin, and the University of Amsterdam. And this research was published in the Journal of Environmental Psychology in 2023, and you are very welcome to take a look at the paper if you are interested. In this study, we explored the association between street network characteristics and analyzed through space syntax and the brain activity related to stress processing. And now I'd like to present you more details about how we conducted the study and how we learned and think from the research result. Okay, could start with watching this street network image of Berlin, and with a simple question: why do more and more people, including myself and perhaps you, choose to live in the city? Most of us would probably agree that cities offer more and diverse opportunities. We enjoy the convenience of urban life, including access to jobs, services, and cultural activities. But as cities continue to expand and urbanization accelerates, we also begin to see the other side of city life, like noise, pollution, and overcrowding. These unavoidable side effects can gradually reduce our quality of life, and one common consequence is stress. Stress is a natural human response to challenges. In moderate amount, it can help us to adapt and perform better. But when stress becomes chronic and unavoidable, it begins to harm our health, increasing the risk of depression, sleep problems, and behavioral disorders. Stress can come from many sources, but one major form of everyday stress is social stress. The stress that arises from interacting from others or from being evaluated by social systems. Unlike the stress from the physical environment, social stress is psychological. It may cause anxiety and discourage people from social interaction and reduce their ability to recover from stress over time. And that's why it's important to consider how urban environments may help people to cope with social stress. Recent studies suggest that urban environments play a role in the recovery process from stress. Urban spaces from both macro or micro scales shape people's daily behaviors and perceptions, and gradually influence how they relate to their surroundings. Over time, this can foster either active or passive stress recovery process. And of course, personal differences such as individual traits also matter in this process. And in our study, we were particularly interested in how the long-term neighborhood living environment affects mental health, especially on the level of brain function. And among many environmental elements that shape everyday life, we decided to focus on one that is often overlooked but highly influential, the street network. Streets are the most common and fundamental type of urban space. They serve a dual function, enabling movement and providing a stage for social life. As cities grow, street networks expand and form the underlying structure of urban form. Compared to other features, such as building density, land use, or specific facilities, the street network tends to remain relatively stable over time. This stability makes it a key contributor to a city's resilience. At the same time, how streets are designed can directly influence people's perception of the environment and their behavior within it. Here is an example. In Frankfurt, Germany, there was a major traffic experiment from 2019 to 2020. A 3-lane road that carried around 20,000 cars a day right along the main riverfront was closed to motorized traffic for a year. During this time, non-motorized users were given clear priority to use the street. And during this closure, the number of cyclists increased by 30%, and the number of children on bikes rose by 3.8 times. And here you can see how the number of children walking or cycling increased during this time. Additionally, we also observed more stationary activities like sitting, eating, reading, and the other types of relaxing activities. This shows that safer streets encourage people to use the space more actively and support more vibrant social and mobility behavior. And return back to the study itself. To capture the characteristics of the street network, we used space syntax analysis. Compared to the traditional method that focus on the quantity of street elements like density of streets or intersections, space syntax focuses on the spatial relationships between street segments. It is based on the topological structure of the street network and reviews the centrality and the hierarchy of spaces. The analysis is based on axis map, and the length of each axis represents the longest street distance one could perceive in a street space. And so the analysis could help us to understand how each axis are related to other axes in the whole system, telling us which streets space are more accessible or central, such as through integration analysis, or which streets are more likely to be chosen for a trip based on choice analysis. In our study, we used 4 space syntax metrics, each links to different types of mobility behavior. First is global integration. It reflects how close a street is to all other streets in the network. Previous research suggests that it predicts car traffic volume. And then local integration. It looks at how close a street is to other streets within 3 topological steps. It focuses on a more local scale and is often associated with walking activity. And connectivity counts the number of streets that are directly connected to a street. It has been related to walking as well as self-reported physical activity. And the last one is normalized angular choice, also called NACH. This identifies the most direct and common roles within the network. It's a kind of new metric in space syntax and has been suggested to related to cycling behavior. We analyzed the 42 neighborhoods in Berlin, Germany, each based on the home address of a healthy male participant. And each neighborhood was defined using a 1.5 kilometer radius, as this is generally considered to reflect a person's daily activity range, and especially for walking and cycling. And for each measurement, we calculated two levels of values. First is the neighborhood level or area level value, which is the mean value of all street segments within the 1.5 kilometers radius. And the second one is street level value, which refers to the value of the street where the participant lived. The area level reflects the general features of broader living environment, while the street level shows the immediate surroundings. Both types of analysis have been used in previous space syntax behavior studies, so we chose to include both. The research was inspired by the idea of neurourbanism, a concept introduced by Professor Mazda Adli, who was also involved in this study. It stresses the importance of understanding how urban and the social environments influence mental health and ultimately on and in the end on human brain. In our study, we linked street network data based on space syntax analysis with brain activity during social stress paradigm to explore the potential associations between them. And to induce actual social stress, each participant completed a task that involved figure rotation and serial subtraction. While doing the tasks, they were under time pressure from a countdown clock and observed by an expert panel. Whenever a participant made a mistake or performed too slowly, they were interrupted with immediate comments like incorrect or walk faster. And in the control condition, participants only did a simple task without pressure or social evaluation. And during the stress paradigm, we collect saliva samples, heart rate data, subjective stress ratings. At the same time, participants underwent functional MRI scanning to measure brain activity. fMRI tracks changes in the blood flow, which could help to identify which brain areas are activated during different tasks. And here is our main finding. So main integration at neighborhood scale, both global and local, relates to weaker brain activations in several brain regions. And this figure actually shows brain regions where activation was negatively associated with street network integration. Red and blue colors highlight the areas with red indicating a stronger statistical significance. These regions belongs to the salience network in our brain, and this network becomes active when we detect some salient or potentially threatening stimuli. And these scatter plots illustrate how integration at the neighborhood level is linked to weaker activation in these brain regions. And in other words, we can say people who live in more connected and accessible neighborhoods showed less reactivity in these salience-related brain areas. This could mean that they were less alert or perhaps more relaxed when exposed to stress. But what explains this link? One likely mediating factor is the level of walking and the social activity in the neighborhood. Areas with high integration tend to support natural movement, meaning more walking and spontaneous social encounters. Previous research has shown that walking and social interaction are related to lower activation in the same brain regions we observed. Social activity may also increase the chance of receiving social support and create exposure to diverse daily stimuli that help build stress resilience. And here are two examples from Berlin. You can see the neighborhood on the left actually is more to the central part of Berlin, and the right one is more at the edge. So below you can see the local integration maps. Red lines indicates streets that are more accessible, and the blue lines are less accessible. And just by comparing, we can have a clear idea that the left neighborhood actually has a higher level of integration. And from the satellite maps, we can also see that this area is actually more likely to encourage more casual exposure to social activity. And this social activity may help residents to develop a higher threshold for perceiving threats or stress, which could explain the reduced activation in the salience network. And another possible mediator is air pollution. A previous study by our colleagues at the Charité found that air pollution was linked to reduced activation in the same brain areas during the stress task. And in our study, we paired street network data with air pollution levels in Berlin and found that highly integrated streets were associated with higher pollution. And the mediation analysis showed that PM2.5 and PM10 partially explained the link between global integration and the reduced brain activation. Actually, this result suggests a kind of trade-off. So highly integrated neighborhoods may offer more social benefits, but they may also come with environmental burdens that affect brain health. So reduced brain activity could reflect both better stress adaptation and neurophysiological cost due to pollution exposure. So as I mentioned earlier, this association found in this study only exists between the neighborhood-level street network integration and the reduced brain activation, not at the street segment level. This suggests that when we try to study the long-term mental health impacts of living environments, it may be more reliable to analyze at a neighborhood scale instead of just a single street. And that's because this neighborhood scale could better reflect the spaces people interact with in their daily lives. And in contrast, street level measures are more context sensitive and may be more useful to understand short-term experiences such as perceived stress or wayfinding decisions. And among the 4 space syntax metrics we examined, connectivity and NACH didn't show any significant association with brain activity. And there are a few possible reasons. First, our sample size was relatively small, only 42 healthy male participants in Berlin, which may have limited our ability to detect more subtle effects. And second, connectivity reflects actually only the direct links between a street and its immediate neighbors. This very local scale may not capture how well our location is connected to the broader network. And we also noticed that the neighborhood with similar connectivity scores could look quite different. Some had kind of walkable grades, while the others had dead ends or natural barriers. So the same score doesn't always mean the same experience. As for NACH, some studies have linked it to cycling activity, but it's still a relatively new metric in behavior-related research. Yes, and also, as we know, like people's mobility behavior is shaped by many other factors as well, like the quality of infrastructure, aesthetics, and perceived safety. So in the future, we recommend linking NACH more closely with actual movement data to better understand its role in shaping stress-related experiences. And in our study, each neighborhood was defined as a 1.5 kilometers radius around a participant's home. We chose this distance because the survey data from Berlin shows that most daily walking and cycling trips happen within this range. So it's a reasonable way to represent people's everyday activity space. However, this localized approach might not fully capture broader network patterns, especially when analyzing global integration, which is closely tied to traffic flow. In some other studies, we noticed that researchers analyzed the neighborhoods as cutouts from a much larger citywide street network. And the benefit of this approach is that all neighborhoods are evaluated within the same global context. So in future work, we hope to reanalyze these 42 neighborhoods using a complete model of Berlin street network and compare the results. And to make it possible, my colleague Gabriela Ornelas has been leading the creation of the access map of the entire city of Berlin since 2023. And it's truly an impressive effort, one that requires a great deal of time and patience. And you can see from these three images, like to see how this map slowly grow. And by this past summer, the access map already covered a large portion of the city, and including like roughly like 440,000 street segments. And having a full map of Berlin like that brings up many new research possibilities. For example, we can include a larger and more diverse samples, and we can incorporate additional mediating factors. And thanks to the open graphic data in Berlin, and we are now able to analyze more variables. And for example, one possible option could be environmental burdens at the neighborhood level. And our research also offers insights for urban design practice. For instance, in newly developed areas, the planning of the street network plays a critical role. Compared to large blocks or dead-end streets, a fine-grained grid-like network allows for more movement, more chance encounters, and a more vibrant public life. This can foster social interaction and potentially support better mental health outcomes. And even in already developed urban areas, there's still room for improvement. By optimizing the existing street network, we could still support mental well-being, since walking and social activity density may act as positive mediators for stress resilience. Improving walkability in both connectivity and quality should be a design priority. And one great example is the Superblock project in Barcelona, Spain. By restricting the motorized traffic, these zones give priority to pedestrians, and through design interventions like public furniture and ground murals, they create more opportunities for people to stay, interact, and enjoy shared space. And in areas where it's difficult to change street network, we can still create supportive environments through tactical urban design. For example, in low integration neighborhoods where walking and social activity tend to be limited, design interventions can help unlock new potential. And one promising approach is through color-based interventions. And this is actually the main focus of my own PhD research and exploring how the color design of sidewalks affects pedestrians' restorative experience in urban streets. And the finding shows that color interventions can significantly enhance the perceived restorative quality of a street. And the design details matter as well. For example, cool colors tend to evoke more positive emotions, while warm colors may reduce the sense of relaxation. So to conclude, our study suggests that improving the structure of neighborhood street networks may be one promising way to buffer some of the negative mental health effects that come with increasing urban density. From a neuro-urbanistic perspective, space syntax gives us a powerful and objective tool to quantify street network characteristics across different spatial scales. And of course, more research is still needed, especially studies that further examine how neighborhood street network features influence mental well-being. So we hope our work contributes to this growing field and inspires future research at the intersection of urban design and brain health. And I believe this kind of interdisciplinary thinking can help us design cities that truly support both physical and mental well-being. And that's it. And thank you for your attention. And I hope you enjoyed this research. And thanks again for having me here, and looking forward to your thoughts and questions.